Bismillahirrahmanirrahim. My name is Abdurrahman and I'm from the Department of PS Chemistry. Today I'm going to give you presentation and my presentation topic is annual production of H2SO4, its application and derivative and the recycling and reproduction of H2SO4. So here is a table of contents, economical importance or annual production of H2SO4, application of H2SO4, derivative of H2SO4, preparation of derivative of H2SO4, and recycling and reproduction of H2SO4. Annual production or the economical importance of H2SO4, sulfuric acid is utilized in many processes. It being one of the primary inorganic material. For a long time, it has been well weathered for the strength of the chemical industry in a particular country. In recent time, a range of large-scale processes have been adopted so that they can operate without sulfuric acid. In addition, recycling of used acid is playing an increasing role. For example, their proportion of federal German production in 1993 was 15% only. Accordingly, the quantities of fresh sulfuric acid produced worldwide has been decreased in recent years to 135 multiplied 10 is 6 ton in 1993, which is still very high. तो जैसे कि मैंने भी एक्सप्लेन किया कि हम लोग सल्फ्यूरिक एसिड जो है वो बहुत सी इंडस्ट्रीज केमिकल इंडस्ट्रीज की एक बैकबोन बना रहा और इसके बाद बहुत सी स्पेसिफिक कंट्रीज जो थी वो उन्होंने काम स्टार्ट किया कि हम लोग इसके बगैर जो है वो अपना केमिकल बनाना स्टार्ट करेंगे तो उन्होंने जो यूज एसिड थे उनको रिसाइकल करने का काम स्टार्ट किया और जिसकी वजह से इसकी क्वांटिटी में इसकी यूजेज में कमी आई और वो थी तकरीबन 135 मल्टीप्लाई 10 जो कि एक स्टिल वेरी वेरी हाई सल्फ्यूरिक एसिड इज वन ऑफ द लार्जेस्ट वॉल्यूम इंडस्ट्री केमिकल्स प्रोड्यूस्ड इन दिस वर्ल्ड तो सल्फ्यूरिक एसिड का जो वॉल्यूम है लार्जेस्ट वॉल्यूम माना जाता है केमिकल इंडस्ट्री के अंदर जो कि दूसरे एसिड्स या दूसरे केमिकल्स बनाने के लिए इस्तेमाल किया जाता है द प्रोडक्शन ऑफ द फर्टिलाइजर स्पेशली फॉस्फेट फर्टिलाइजर्स फ्रॉम वेट प्रोसेस फॉस्फोरिक एसिड हम लोग इसे फॉस्फेट फर्टिलाइजर तैयार कर सकते हैं फॉस्फोरिक एसिड के वेट प्रोसेस से इज अ मेजर एंड यूज मार्केट फॉर सल्फ्यूरिक एसिड अकाउंटिंग फॉर ओवर 60% of the total world consumption in 2020. This share is expected to slightly decrease through 2025, mainly because metal leaching and the steel pickling applications are expected to grow at high rate. About 14% of the global sulfuric acid is consumed for about 20 chemical process. Major growth drivers on a global level in decreasing order are used for phosphoric acid, metal leaching, ammonium sulfate, and titanium oxides. So we can see in this pie chart the production of H2SO4 in various countries. So here's a China. Just a second. Okay, you can see that China is the largest productions of the H2SO4. After that, America produced secondly highest amount of H2SO4, and the end of um the other countries produce H2SO4. So China produce in the annually 74 million tons, USA 37 million tons, India 16 million tons. At the end of Russia 14 million tons produce H2SO4. Application of sulfuric acid being a key product in the chemical industry has many applications worldwide. 65% is utilized in the manufacturing of phosphorus and nitrogenous fertilizer, whereas in the Western Europe only 31% is also utilized. In the Federal Republic of Germany, 90% of the sulfuric acid produced in the utilized in the chemical industry. And in the petroleum industry, petrochemical industry, sulfuric acid is utilized, for example, in the alkylation of isoalkane with alkenes in the chemical industry, in the manufacture of inorganic chemicals. And organic products like dyes, explosive, isocyanate, soaps, detergent, fibers, and pharmaceuticals also produced by sulfuric acid. Sulfuric acid is also utilized in the manufacturing of titanium oxide, pigment, uranium, and copper extraction in steel, pickling, and in batteries. The major use of sulfuric acid is the production of fertilizer, superphosphate of lime and ammonium sulfate. It is widely used in the manufacturing of chemical like making hydrochloric acid. So as I mentioned before, various kinds of acid we can produce by H2SO4. So, in making hydrochloric acid, nitric acid, sulfate, salt, synthetic detergents, dyes, and pigment, explosives, and drugs. It is used in the petroleum refining in wash impurities out of gasoline. So we can use it to pure our gasoline, petrol, and other refinery products. Sulfuric acid is used in the processing metals in pickling iron and steel before plating them with tin or zinc. We can use it for cleansing of iron and plating them with the tin or zinc. Rayon is made up with sulfuric acid. It's another compound. It's serve as an electrolyte in the lead acid storage battery commonly used in the motor vehicles. Derivatives of sulfuric acid. Phosphoric acid is one of the most important and useful mineral acid. It is non-toxic and it is also commonly called as orthophosphoric acid. Its formula and structure you can see here. The chemical formula of phosphoric acid is H3PO4. Its molecular formula is written as H3O4P, and its molar mass is 97.99 gram per mole. The central phosphorus atom is connected to an oxygen atom through a double bond, and the three hydroxyl group through a single bond. So we can see that there is three hydroxyl groups which is connected with phosphorus with a single bond, as well as oxygen is attached with phosphorus with double bond. Thus, H3PO4 can release up to three hydronium ions. Now we will learn how we can prepare its derivatives. Phosphoric acid is produced industrially through a wet process in which sulfuric acid is reacted with apatite, which is tricalcium phosphate rock. So here is a reaction in which we can prepare its derivative like H2SO4 and other derivatives. The resulting phosphoric acid is solution is only about 32 to 46 Ht phosphoric acid. So it is then concentrated by evaporation of water. So we can concentrate it by evaporation of water to produce higher concentration commercial grade of phosphoric acid to produce in larger quantity of H2SO4. Aluminium sulfate, it is another derivative of sulfuric acid, is a chemical compound with formula Al2SO4 3. It's soluble in water and is mainly used as coagulant agent in the purification of drinking water. So everybody knows that aluminium sulfate is also used as a cleansing agent for water, and we can use it in the treatment of water. So aluminium sulfate may be made by adding aluminium hydroxide to sulfuric acid. So you can see in this reaction, aluminium sulfate react with H2SO4. Aluminium hydroxide react with H2SO4 and it produce aluminium sulfate and 6 mole of H2O. Or we can also produce it by heating aluminium metal in sulfuric acid. In the presence of H2SO4, when we heat aluminium, so we can also produce aluminium sulfate. And in this process, hydrogen gas will be liberated. Diethyl sulfate is highly toxic and likely carcinogenic chemical, which is cause cancer. Compound with formula C2H5 2SO4. It occurs as a colorless, oily liquid with faint peppermint odor and it's corrosive. Diethyl sulfate is used as an alkylating agent to prepare ethyl derivatives, phenols, amines, and thiols. We can prepare amines, thiol, phenol, as well as ethyl by diethyl sulfate. It is used to manufacture dyes and textile. Its major uses in the dyes industries or textile industries. So, preparation, it can be prepared by absorbing the ethylene into concentrated sulfuric acid. We can prepare it by adding ethylene into H2SO4 uh, or by fuming sulfuric acid into diethyl ether or ethanol. Now we will see how we can recover and recycle our sulfuric acid in commercial level. Acid is used as a catalyst, is often contaminated with organic material. Recovery and concentration is possible in this case. When we use acid in as a catalyst for example, if we use it for the pickling process or picking process or cleansing process of leather or metals. So some organic material contaminate this acid. So we can recover it by different process. This the acid is preheated and fed into stripping column, which remove the organic material using them. We can preheat the acid and fed into stripping column. It's a process we will see in the diagram in the next slide, which remove the organic material using steam. So we can remove the contamination, some contamination by using steam. The acid is then vacuum distilled to concentrate it. Then we will vacuum it to concentrate it. Important features in the process of designated by Cuvender chematics are heated from the products. Acid is recovered and used for preheating the feed acid, reducing the energy needed in the process. So when we use preheating process, it reduce our energy needed. So it's become less expensive. Much of the liquid flow uses gravity rather than the electric pump, saving on energy and the cost of using acid resistant pump. The reaction vessel must be acid resistant, and these are made from glass or Teflon line steel, which cannot be react with the metal with acid. So here's the diagram. We spend acid in this, and we will preheating this acid. After that, this is the stripping column, and we generate a steam, and then distillation. Second process is distillation, and then we can cool our regenerate sulfuric acid. Pre-concentration, the spent sulfuric acid is first concentrated to remove water and so reduce the volume being handled. This means a smaller furnace can be used and less energy is needed for the second stage. As we know, we will preheat our acid, and in the next step, there is a smaller need of energy. The degree of concentration depends on the dissolved impurity. Concentration stop at the point these begin to precipitate. Thermal cracking in regeneration furnace in the second stage, which is a region thermal cracking is the second stage. In this stage, the concentration concentrated is mixed with compressed air and sprayed into a furnace heated, which is a temperature roundabout of 1000 and to 1200 centigrade. Cracking the H2SO4 molecule into sulfur dioxide and steam. When we heat it with 1000 centigrade or the 1200 centigrade, it's break the molecules of H2SO4 and convert it into sulfur dioxide and water molecule as well as oxygen. The best result are obtained if the residence time is about 3 seconds. Although this reaction is endothermic, energy from the other processes in plant may be used for preheating, reduce the energy demand. Energy must in fact be removed after cracking, and this can be used to preheat the spent acid or to raise the steam for power generation. So, as I mentioned before, some acid is used as a preheating. So we can use because it's an endothermic reaction. So for reducing its energy, we use as a steam or as a preheating fuel. Regeneration by cracking, in case where the acid cannot be recovered by stripping and distillation, an alternative can be used. If there is acid which cannot be purified or recycled by stripping process or the distillation process, we have seen two processes in which we recover or recycle our H2SO4 by stripping process, and other is distillation process. But if our H2SO4 is not be purified or recycled or regenerate by these two processes, so we can use SARTCO process, sulfuric acid by thermal cracking oxidation. Break the acid down to produce sulfur dioxide, which is then used to produce more sulfuric acid by the contact process. So in this step, we will break the sulfuric acid into sulfur dioxide, and then we will more sulfuric acid by using sulfur dioxide. The gas stream uh, so the gas steam is introduced into a drying and the purification unit where any organic product, volatile metal, solid ash, impurities, sulfuric acid, which are removed by cooling and by electrostatic filter. So in this container, in this container, we we generate electrostatic filters, and we set electrostatic filter, or by removing, by cooling, we can remove impurities in our H2SO4. The remaining gases, which are sulfur dioxide, oxygen, nitrogen, and steam, are dried in 98% sulfuric acid before being reheated and entered into the contact process to make a new phosphoric acid. So we discuss this, when we use this process, we can dry our 98% sulfuric acid before reheated and entered into the contact process to make new sulfuric acid. This is a process. The spent sulfuric acid, here is a pre-concentration. After that, we add compressed air to remove our solid or some other gases. So after that, we shift it into regeneration furnace. Here is a temperature of 1000 to 1200 centigrade, and then we convert it into sulfur dioxide and H2O. After that generation of high pressure, we built a high temperature atmosphere in this container, and after that we cool this heat exchanger with heat exchanger, and we apply feed gas cleansing, and then we can manufacture our H2SO4. Thank you. That's all my side. Thank you so much.